In this tutorial, we'll develop a basic C# application and focus on the data types used in building the application. We'll look at the differences between value types and reference types, and how the data types that fall within these two main data type categories are stored and managed in memory. By the end of this tutorial, you'll have a comprehensive knowledge of C# data types. Okay, let's get started. Welcome to Gavin Digital. Hi everyone, my name is Lon. This is the second part of the C# for Beginners course. If you haven't seen the first part of this course, an introduction to C#, please see in the description below a link to the first part of this course. And please don't forget to subscribe so that you can be notified of future content. Okay, let's start by building a simple C# application. But before we leap into writing code, let's answer the question, what are data types? Most programming languages include the notion of data types. Data types define the rules associated with the operations that can be done on the data. Data types define the meaning of the data and the way values of data types can be stored in computer memory. C# is a strongly typed programming language, and C# data types run within a type system known as the common type system. A strongly typed programming language like C# is one in which each type of data, such as integer, character, decimal, string, boolean, and so forth, is predefined. All constants or variables defined for a given program must be described with one of the data types. In this strongly typed programming language, type-related errors can be preempted at compile time if data type-related code is deemed as not compliant with the rules defined in the common type system. What is the common type system? The common type system provides a standard that specifies type definitions and how specific values of types are represented in computer memory. The object type is the ultimate base class for all data types in the common type system. Let's create a depiction representing a hierarchy of C# data types, and we'll add to this when appropriate as the tutorial progresses. The root element of the hierarchy is the System.Object class. Variables defined as object types can be assigned values of any other types. What is a variable? A variable is a name in code given to a data value. The data value associated with the variable name can be changed by assigning the variable a different value appropriate to the data type with which the variable is defined. Okay, let's write a basic C# application. We'll be using inbuilt C# data types in this application. Inbuilt simply means data types provided in the C# language. This is in contrast to user-defined data types, where a group of inbuilt data types can be used to build a custom type. I've already gone through the project creation process, and as you can see, I've created a project called Employee Application. The project creation process was demonstrated in the first part of this course, so for more detail on the project creation process, please watch the tutorial entitled An Introduction to C#, which is the first part of this course. A link to this tutorial can be found in the description. I'm using Visual Studio 2017 Community Edition for Windows to develop this application. Please see in the description below a link to where you can download Visual Studio Community Edition for Windows, which is offered by Microsoft free of charge. There is also a version of Visual Studio 2017 Community Edition available for Mac OS. I've also included the details of where you can download this in the description. I chose the .NET Core Console application project template for this project. In this application, we are going to appropriately define a group of variables for an employee record. The function of this application will be to accept data from the user for each of the variables and then output a brief narrative describing the employee based on the data entered by the user. The first variable is named employee ID and defined as the integer data type. The value stored in this variable will serve as a unique identifier for an individual employee record. Well, we are only going to refer to one employee in our code example, but in the real world, this integer variable would be useful if we were dealing with hundreds or thousands of employees. Let's initialize the employee ID variable to 0. An integer is a 32-bit data type and inherits from the System.ValueType base class. Let's add the ValueType base class just below the System.Object class in our representation of C# datatypes hierarchy. And then add the int32 datatype directly underneath the system.ValueType base class. I have referred to the integer datatype by its struct name system.int32. Here is a basic definition of what a struct is. A struct is a data structure similar to a class, but unlike a class that is a reference type, is a value type, which means it stores its own copy of its value in memory. However, like a class, it also supports, for example, fields, methods, properties, and events. Unlike a class, the developer can instantiate an object from a struct without using the new keyword. I have used the int keyword to define the employee ID variable in code. I could have defined the employee ID variable by using the system.int32 struct for this purpose. Please note that the keyword int serves as an alias for the system.int32 struct. When we say a datatype, for example, is a 32-bit datatype, this means that this datatype is constrained to 32 bits of data for the representation of a value in memory. The number of bits used to represent a value is directly related to the magnitude of the range of values supported by the datatype. Variables defined as an integer store whole number values and are value types. Other integer data types in C# include byte, which is a 1-byte or 8-bit data type, short integer, which is a 2-byte or 16-bit data type, long integer, which is an 8-byte or 64-bit data type. Byte, short, and long are aliases for the following structs listed respectively: system.byte, system.int16, and system.int64. Let's pause for a moment. There's terminology that is tied to C# data types with which you may not yet be familiar. Let's take a look at this terminology. As terms come up that need defining, we'll push them onto a terminology stack. Each term is represented by a box, one stacked on top of the other. As these terms are defined, the term will be popped off the stack and we'll move to the next item on top of the terminology stack. We'll repeat this process until all the boxes have been popped off the terminology stack. C# data types can be put into two categories, value types and reference types. Let's push reference types and value types onto the terminology stack. Let's look at value types. A value type is a type in C# that inherits from the value type base class. Let's push the term inherit onto the terminology stack. All types in C# ultimately inherit from the system.object class. Value types inherit from the value type class, and the value type class inherits from the system.object class. A variable defined as a value type stores its value directly in memory. Reference types store a pointer to its data and not the data itself. The data itself is stored in a different location in memory. Value types store their data directly in memory. The part of memory where value types are stored is known as the stack. Let's push the term stack to the top of the terminology stack. Stack. The stack is a fixed length location in memory allocated to each of the threads in an application. Let's push the term thread to the top of the terminology stack. Fixed length variable types are stored one on top of the other on the stack while a sequence of instructions is executed for a thread. These values are processed on a LIFO or last in, first out basis. Thread. A thread of execution is the smallest sequence of programmed instructions. Our employee application, for example, is a simple application that requires only one thread. A more complex application could invoke multiple threads. Each of these threads can run in parallel asynchronously, which can greatly increase the performance of the application. Inherit. C# is an object-oriented programming language, and inheritance is a fundamental principle of object-oriented programming. Inheritance allows, for example, one class. Let's push class onto the terminology stack to be based upon another class. Class. A class is a group of related types, methods, and events. It serves as a blueprint for an object. A class is a reference type. The new keyword is used to create an object from a class. Reference types. Reference types inherit directly from the system.object class, which is itself a reference type. A variable defined as a reference type, for example a string, which is a data type we'll discuss a bit later, stores a pointer or memory location to where the actual data resides. The memory location information is stored as a numeric value on the stack, and this value points to a portion of memory that resides in a memory location known as the heap. Let's push the term heap onto the terminology stack. The heap. The heap is a location in memory that is not constrained by a fixed length. It is used for the storage of object data. Data is stored in a more haphazard way on the heap when compared to the orderly way that data is stored on the stack. As a result, memory management applied to the heap is more complex and therefore less efficient than memory management applied to the stack. Unlike data stored on the stack, the data stored in the heap is not constrained by a fixed length. The size of the object data stored on the heap is only constrained by the physical resources of the computer on which it resides. Right, let's define a variable to store the employee's first name, which we'll define as a string data type. Note that the string keyword is an alias for the System.String class. Let's initialize its value to an empty string. As mentioned earlier, the string data type is a reference type. Let's define a variable to store the employee's last name. This variable will be defined as a string data type. Let's initialize its value to an empty string. Let's add the string data type to the C#type hierarchy directly under the System.Object class. The string data type is a reference type. Let's define a variable as the decimal data type to store the employee's annual salary. This data type is a value type, so let's add this under the value type base class in the C# data types hierarchy representation. The decimal data type can store 128 bits of data. Variables defined as this data type can store both whole numbers and floating point numbers. There are two other floating point data types in C#, namely the double and the float. Note the float keyword is an alias for the System.Single data type. The decimal data type can support a greater precision and less magnitude than the double and the float, which makes it ideal in financial and monetary calculations. Note that I've used the decimal keyword to define this variable, but could have used the struct System.Decimal for the same purpose. Let's define a character data type to store a character that will represent the employee's gender. Note char is an alias for the struct System.Char. The F character will denote the female gender. The M character will denote the male gender. Let's add the char data type to our C# data type hierarchy. A char data type is a 2-byte or 16-bit data type. Variables defined as the char data type store Unicode values. These Unicode values are represented by 16 bits of data, and each Unicode value is an encoding of a character. For example, the lowercase f character is represented in memory by a value of 102. A lowercase g is represented in memory as a value of 103. A lowercase h is represented in memory as a value of 104. What is Unicode? Unicode is a computing industry standard for the consistent representation of text for most of the world's writing systems. Unicode can be implemented by different character encodings. Let's define a variable to store a value that denotes whether the employee is a manager or not a manager. Let's call this variable isManager. Let's add the boolean data type to our C# type hierarchy. Boolean is the ideal data type to define this variable. The boolean data type stores one of two values, true or false. As you can see, we are using the console class's WriteLine method to prompt the user for a value. The readLine method will ensure that the prompt remains on the screen until the user presses the Enter key to confirm the user's data entry. Let's write the code to assign the user input to each of the variables we have defined. The console static class's readLine method is used to return the user's input. Note that this method returns data as a string data type. We cannot directly assign variables that are not defined as a string to the string value returned by the readLine method. This would result in a compile time error. To avoid a compile time error, we need to first appropriately convert the string value returned by the readLine method into the same type as the variable that will be assigned the value entered by the user. This is achieved by using appropriate type conversion methods made available to the developer through the Convert static class. To implement the appropriate conversion operation, we simply pass the readLine method's return string value into each appropriate conversion method as a parameter before assigning the user input to the appropriate variable. So you can see the employee ID user input is converted to an integer data type using the toInt32 method. The annual salary user input is converted to a decimal data type using the toDecimal method. The gender user input is converted to a char data type using the toChar conversion method. The isManager user input is converted to a boolean data type using the toBoolean conversion method. Let's build the output narrative describing the employee based on the user's input. Let's define a string variable called narrative. We are going to build a string using concatenation. What is concatenation? Concatenation is the operation of joining more than one string from end to end. The plus equals operator is used in code for this purpose. So let's assign the first part of the string to the narrative variable. Let's then append the second part of the string to our narrative by concatenating the second part of the narrative to the first part of the narrative. Let's then append the third part of the narrative through another concatenation operation. And this part of the string needs further attention. The user's gender is currently stored as a character. The problem with this character value is that it does not work with our narrative. We want something more human readable in order for the narrative to read correctly. So we are going to apply some conditional logic in order to include text that is more appropriate to the output narrative. We are going to assign a string value called genderTerm to what is known as a ternary operator. A ternary operator enables the developer to test a condition and return an appropriate value based on the results of the test condition. A variable can be assigned the returned value. Through the use of the ternary operator, this can all be done in one line of code. If gender is equal to the F character, then output the text female, else output the text male. The literal string value on the right of the question mark and before the colon is returned if the test condition returns true, and the literal string value on the right of the colon is returned if the test condition returns false. Let's include the genderTerm variable in the output narrative. We also want to apply similar logic for the isManager variable for the same reason, ensuring that the narrative is more human readable. So let's assign a string variable called manager narrative to a ternary operator. Let's include the manager narrative in our output string. Note we are using string interpolation to include our variables directly within the string narrative output. This signifies to the C# compiler that the variable names included directly in the string must not be interpreted as literal string values, but the values stored within the variables must be merged with the string literal in which they are included. Let's append the fourth part of the narrative to the narrative output, and this is the last concatenation operation. Okay, let's finish off the application by writing code to clear the console screen. Then let's include code to write the output narrative to the screen. The Console.ReadLine line of code forces the screen to stay open when we are running our code interactively through the Visual Studio IDE. The console screen will remain open until the user presses any key, which will close the console screen. Okay, I can see a little issue here. The word is would have appeared twice because it is already included in the narrative. So let's remove it from the ternary operator code. Right, let's run the code. While we run the application, I'm going to present an allegorical representation of how data stored in our variables for the data types is represented in memory. Boxes will be used to represent the data stored in our variables. The configuration for the boxes will represent how each of the data types is handled in memory in terms of the stack and the heap for value types and reference types. Let's enter an ID of 1 for this employee and press the Enter key to confirm our data entry. The employee ID variable defined as an integer, which is a value type, means the value is stored directly on the stack. First name is Sarah. See how a number is pushed onto the stack for the string variable. This number represents the location of where the data for this variable is stored on the heap. All memory addresses used in this example are arbitrary, and used to demonstrate that a numeric value is put onto the stack for reference type variables. This value points to the actual object data that is stored for the string variable on the heap. Last name is Johnson. Sarah earns the following annual salary, which is a good example of a floating point value. This employee is a female employee, so we'll enter the character F to represent the employee's gender. The value for the gender variable is stored directly on the stack because it is stored in a variable defined as the char data type, which is a 16-bit value type. And the employee is a manager, so we entered true for this field. Associated with the gender variable is the genderTerm string variable. This variable is used to store a more human-readable term to represent the employee's gender in the output narrative. The variable used to store the genderTerm value is defined as a string. This means a numeric value is pushed onto the stack. This numeric value represents a memory location of where the data for the variable is actually stored on the heap. Like the gender variable, we created a more human-readable string to represent the managerial status of the employee. We used a string variable named manager narrative for this purpose. So a numeric value is pushed onto the stack. This numeric value represents a location in computer memory where the actual data for the variable is stored on the heap. You can see value type variables are stored one on top of the other on the stack, and our string variables, which are reference types, store their data on the heap. A pointer to the data stored for each of the reference types is stored on the stack. The isManager field is the last input field, so when we press the Enter key, we should see our output narrative describing the employee. Let's press the Enter key. But before we show the output, let's continue with our abstract example and show what the concatenated string for the narrative variable looks like after each concatenation operation occurs. You can see that with each concatenation operation, an entirely new string object is created. With each concatenation operation, an accumulated result is created from the previous concatenation operations, as well as the newly concatenated string. And only one of these string objects is in fact referenced from the stack at a time. This is because a string is immutable. Immutable means data cannot be added to another string's data directly in memory. A new memory allocation is created each time a concatenation operation is performed in building a string, and with each concatenation a numerical reference is updated on the stack with the new location of where the new string data object resides on the heap. This leaves the string data object created by the previous concatenation operations lying on the heap without references. This means that these string data objects are eligible for garbage collection. Internally, a string object stores a read-only sequence of char objects. The data stored for a string object is immutable. So let's look at the final output. Employee with an ID of 1, whose full name is Sarah Johnson, is a female employee who is part of the management team. This employee earns an annual salary of £60,000.1345632178. Here are some other C# data types that were not included in the employee application. These data types are beyond the scope of this tutorial. This is because each of these data types will be discussed in more detail in upcoming tutorials. Here is a brief explanation of each of the data types. Enum. An enum is a value type consisting of a set of named constants. The enum keyword is used to declare a list of named integer constants. Delegate. Delegates allow the programmer to encapsulate a reference to a method inside a delegate object. Delegates are reference types. All the delegates are implicitly derived from the System.Delegate class. Dynamic. C# is a strongly typed programming language, which means the C# compiler enforces rules upon the developer's code at compile time to preempt type-related runtime errors. The dynamic type allows the developer to bypass these imposed C# compiler rules at compile time. Instead, it resolves type at runtime. The dynamic type is a reference type, which in most circumstances behaves like the object data type. Array. Array types are reference types, which are derived from the abstract class type System.Array. An array in C# is a fixed-size sequential collection of elements of the same type. The elements are stored in contiguous memory locations. Datetime. The datetime value type represents dates and times, with values ranging from midnight, January the 1st, 1st century Anno Domini, Common Era, through 59 minutes and 59 seconds past 11 p.m., December 31st, 9999 AD, CE, in the Gregorian calendar. Time values are measured in 100 nanosecond units called ticks. A particular date is the number of ticks since midnight, January the 1st, 1st century AD, Common Era. For example, this literal value, which as you can see has an L suffix meaning it is a long integer literal value, is the amount of ticks that have occurred between the date midnight January the 1st, 1st century AD or Common Era, and the date 4th of April 2005, 10 minutes and 1 second past 10 a.m. We have covered the common inbuilt data types in C# and used some of these data types while building a basic C# application. We discussed the difference between value types and reference types. At appropriate points in this tutorial, we have updated a depiction representing a hierarchy of C# data types. The stack and heap memory locations were briefly discussed in terms of how data types are stored in memory. We briefly looked at some of the data types that were not included in the employee application, including enum, delegate, dynamic, array, and datetime. Please see the description below for details regarding any supplementary information associated with this tutorial. All code and related documentation can be downloaded from the Gavin Digital GitHub repository. Please hit the thumbs up icon if you feel you have gained value from viewing this tutorial. And please subscribe. If you are already subscribed, please hit the bell icon to be notified of future content, which will be coming soon. Thank you.